Welcome to Brain Vision.
Hello everyone, here it is given. The ends of a rod AB of length 25 inch having the mass or weight 9 pounds are connected to move along the slots cut in a vertical plate attached to the spring of spring constant 3 pounds per inch. Attached to the NA in such a way that tension is 0 when theta is 0. So at theta to be 0, tension in the spring is 0. That is force, you may say. Don't get confused with kinetic energy. If the rod is released from rest, so at theta to be 50 degree, it is at rest. We have to calculate angular velocity and velocity of V, angular velocity of rod and velocity of V point when theta is 0 degree. Let us start solving it. See the geometrical figure of the given situation. This is the spring, rod A and AB, and this is B. This is centroid. Here weight will act. This angle is given 50 degree. This is x1. If we draw the perpendicular from here, this will be, this is length L, this is 50 degree, this is 90 degree. So it will be L cos 50. And this value, if you calculate, it will be L sin 50 by 2, sorry. This is the position 1. Now see the position 2. Spring. Rod AB. G. This will be L by 2 each. This is the instantaneous center. Its weight will act in this direction. Vg omega 2. Now, velocity of center of mass V2 will be Ly2 omega 2. Velocity of V point will be L omega 2. X1 L minus L cos 50. L is given 25 inch. So it would be 8.9303 inch. So in position 1, its potential energy you may calculate. Weight L by 2 sine of 50 plus half k x1 square. Putting the value, weight is given 9 pounds, so mass will be 9 upon g, that is 32.2. Length is given 25 inch, so 25 by 12 into 1 by 2. Sine of 50. Spring constant is 3. X1 we have calculated. So on solving it, potential energy of the system will be 33.45 pound into inch, or you may write 2.787 feet into pound. Initially, the system is at rest, so its kinetic energy will be 0. Now position 2, potential energy will be 0. Kinetic energy is half m v2 square plus half I omega 2 square, half m v2 we have measured omega into Ly2 square, half moment of inertia will be mn square by 12 into omega 2 square. Calculating this value, it can be written as 1 by 6 ml square omega 2 square. Substituting the mass, 9 upon 32.2, length is 25 inch, so final kinetic energy of the system now applying the conservation of energy. Sum of kinetic energy and potential energy in position 1. is equal to sum of kinetic energy and potential energy in position 2. In initial position, kinetic energy is 0 and potential energy we have measured 2.787. In second position, kinetic energy we have measured 0.2022 omega 2 square and potential energy is 0. So omega 2 we will get 3.7 radian per second. This is answer of A part. Now velocity of point B, L into omega 2. L is given 925 inch, so 25 by 12 feet into 3.713 feet per second. So final answer for velocity of B point of the rod 7.74 feet per second in upward direction. That's all for it. Thanks for watching it.